Hello and welcome to the BMC Learning Series. Today we'll be covering MainView SRM Allocation Part 3. If you have not taken the first two parts, please do that first. In this final section of the three-part series, we will pick up on SMF reporting and analysis functions. The SMF reports could produce a large quantity of output data. As illustrated here, the dump process to extract the Type 201 records is the IBM IFAS-MDP dump program. SRM provides the ability to read the records from both the traditional sys1.man files as well as the newer logstream process of SMF. The SMFX37A job that is found in the BB-SAMP library is used to report on jobs that failed with an X37 abend or space not available condition. It reads the SMF Type 30 records. This job is useful to help determine the types of rules that will be implemented and datasets to include in the allocation functions. You should execute this job before implementing SRM allocation, and then execute it again on a regular basis to check the system for any conditions missed in the original analysis. A quick look at the JCL for the X37A job. Please note that the JCL is already defined to only read the Type 30 record. We will look at the PARM statements on the next slide. These PARM statements are used to assign costs and time wasted because of the abends. The default values are listed here. There are many values for the average cost per hour for a person's salary, the average cost per hour for CPU, currency value, and the average number of minutes it takes to manually resolve an out-of-space condition. The output of the X37A report lists the jobs that abended, an owner if available, the program that was executing when the abend occurred, the time of day of the abend, the type of abend, the amount of CPU time consumed before the abend, and the elapsed execution time before the abend. The second part of the X37A report gives a numeric summary of the costs, the number and the type of abends. The values used on the exec statement are used to calculate these values. The savings values are calculated for the period of SMF data collected, and then projected out for 1 year if no changes are made and the errors continue. The SMFX37B report is a report to review the actions that allocation has taken, as well as the actions that allocation failed to recover because the solution was told not to take an action. There could be multiple recoveries, both for different functions and the same function within one job. The resulting output lists all the details of the recovery action, similar to the X37A report listing the abends. The JCL for the X37B report includes a sysin statement that provides a hex value for the SMF record for SRM. For record 201, the value is hex Charlie 9. If you wish to use a different SMF record and you want to use the X37B report, you must change the value from Charlie 9 to the valid hex value for the new SMF record that is chosen. The rec ID is also listed on the PARM statement of the SMFX37B program exec statement. Much like the X37A report, there are PARM values to assign values that are used in the valuation of the cost savings of the recovery actions that have taken place. For the X37B report, there are additional PARM values that can be used along with the rec ID value to customize the inputs that are used for the report. For example, the R-type can limit the functions considered. XSTC can exclude certain started tasks. And STEP is used to determine the time lost based on job execution time or step execution time. An example of the X37B output, listing each job that received a recovery action, the type of action, the data set recovered, the step name, and other date-time information. The second half of the report contains the cost savings information based on the recovery actions taken and the values specified on the PARM statement. The third job that can provide allocation analysis of actions taken is the PR SMF000 utility. The job name in BBSAMP is called JCL SMFL and creates a partitioned dataset where each member name corresponds to a function that was used to provide space recovery. A sample of the JCL SMFL JCL. As with both the X37A and X37B jobs, the input is SMF data. This job uses the allocation SMF record as input. Here's a sample of the PR SMF000 SMF utility PDS output. As noted, each member is the name of a function. When browsed or edited, the member will display all of the actions taken for that function in chronological order. Here we illustrate the flow of a typical recovery of non-VSAM dataset. Space not available is handled by SPAC prime. Once allocated, a number of the SPACsec functions could be invoked, along with SPAC valet. For VSAM datasets, the recovery process is similar. Messages are sent to the syslog and job log, in addition to the SMF record getting cut. When working with allocation, there are many best practices that are recommended. Sim mode will allow you to test any recovery rules while running the functions in simulate mode. Messages are displayed in simulate mode. However, the message prefix has an asterisk associated with the SVM message to identify the action as simulated. The Use Cat Global option specifies whether to use the catalog name and should be used carefully as it works with the ACS replacement functions. VSAM prime is useful for a volume switch of the VSAM datasets in order to use the primary allocation size instead of the secondary. This global option does not apply to DB2 and multi-stripe datasets. Shared VSAM is almost a must to code in the global PARMs in order to volume extend VSAM datasets that are shared, including DB2 datasets. The default value of this PARM is yes. VSAM ADJ4GB is advantageous to recover non-extended VSAM datasets that approach the 4 gig limit by automatically adjusting the primary and/or secondary to prevent an error. The VSAM lim warn will display a message when non-extended VSAM datasets exceed a defined threshold percent of the 4 gig limit. OpenEMPT prevents return code 99 errors and DFHSM by properly closing the dataset. Opt block size can be used to assign system-determined block size, even if the user assigns a block size other than 0. Other block sizes can be assigned for specific datasets. sksup can be used for splitting the unit affinity between STK silos. Mod delete works with the mod delete function to prevent recalls of migrated datasets during the BR14 mod delete step in batch job. SPACsec-A is assigned during the first extent request. Using event ID in SPACsec-I is useful for tracking secondary space increase if the increase is frequent, possibly a looping program. SPACsec-B gets control before ZOS attempts the secondary attempt and is not used for multi-striped datasets. SPACsec-R gets control after the ZOS has failed the secondary extent during an EOV call. It's recommended to not use a small decrement value here. For nocatalog 2, do not forget to use nocat SMS and nocat TIM in the global member. For SPAC prime, do not use a 1% or lower decrement value. If a value of 0 is used for the floor limit, allocation will occur without any space, causing SPAC valet to be invoked if active. For SPAC valet, a good rule of thumb is no more than 5 to 10% of all recoveries should be volume adds. You can extend shared VSAM datasets, including DB2. SPAC valet uses less storage than the DF SMS DVC option in data class, and you can track the volume number uses through the SVM messages that are displayed with SPAC Valet. For SPAC SWIR, again, a low decrement value is not recommended, and it will be invoked before SPAC SecR and SPAC Valet if a candidate volume list is used by the user. Great tools to validate and manage allocation function activity is achieved through the use of the SIM parm in the F-list members, batch jobs FMSX37A and B, JCL MFL, JCL SMFL, and JCL UTIL-C. Using ReduceXT can be used to reduce multi-volume datasets after SPAC Valet has completed. Here's an example of the online report of the recovery actions. The view is available in both the GUI and ISPF interfaces, providing a chronological order of the actions, both successful and unsuccessful. The unsuccessful actions could be because the rule excluded the data from being processed, or the dataset was made inact in the F-list member of the function. That's it for this series on MainView SRM allocation. For more videos on MainView and other BMC solutions, please visit our BMC Mainframe YouTube channel at youtube.com/user/BMC Software Mainframe/featured. Thank you and see you next time.